Hello, students. It's your favorite instructor here, and I'm going to be doing the week 2 and week 3 video. And so what's going to happen here, let's talk about how this works. So the way this works is I will do the lectures and the exercises all in one video. And like I have said, your assignments will not be due until halfway through the term, which I will put that date up on Canvas. And so you just need to work through this at your own pace. Try to keep ahead of the curve a little bit on it. If you're doing, so I'm calling this week 2 and week 3. So that should tell you that you have about 2 weeks or 10 days or so to work through this if you're trying to just keep track of your schedule and stay on top of things. And so this first lecture will be on what GIS is, and we'll go through that, and then I will show you how to download the data off of Canvas and set up your file structure, and then where you should be saving everything on your computer, and then that is what you will end up turning into me. And like I said, if you want to know how you're doing, you can always send me something and I will check it for you. But we're just going to do it all as one large assignment, so you'll have 2 large assignments and a midterm and either final exam or final project. I have not decided which one it'll be yet. And those are your points out of 1,000 points for the term. So let's talk about what is GIS. And so in this first lecture, we're going to be covering what GIS is, some different concepts about data models and file types. And these kinds of things will show up on the midterm. So I encourage you to study this and go back through it. And I will include these slides as a Word document on Canvas, so you can download that and use it to study. I can't do it as a PDF because the PDF doesn't export in the right size for some reason. So what is GIS? Well, GIS technically stands for Geographic Information Systems. I like to make the old joke that students always really laugh at, that it stands for Guaranteed Income Stream. That's not totally a joke, though, because it really does guarantee you an income stream. There are so many different disciplines now that we can see here at the bottom that use GIS. So GIS as a software came out in about the late 80s. And what happened was the surveying community kind of poo-pooed it, that's a technical term, when it came out. And because they didn't think it would ever be precise enough or have the level of precision they needed, which actually is incorrect. And so the natural resource and environmental science community picked it up and they just went gangbusters with it. And then about 15 years after that, the surveying community then actually sued to try to make it so you needed a surveying license to use GIS, but that got shot down, thank goodness, because I'm not actually a surveyor. And now the surveying community, civil engineering, they've all hopped on board and they use it all the time now as well. And so if you're looking at population health management, I've seen it now used in the medical community, like mapping the human body even, which is pretty awesome. And natural resources, municipal GIS, so cities, things like that. It's got a wide range of application. Programmers are now getting into it a lot the last 10 years or so because it's very customizable using different programming languages. And so it stands for Geographic Information Systems. And so technically, any like paper map is a GIS because it's a Geographic Information System. But more accurately, the term refers to different software that has particular things in common. And we'll talk about that as we go through the slides here. There are 4 key components to a GIS, and that's the hardware, the software, the data, and the people. So your hardware is the computer, or even like the GPS unit or your phone that you are doing the analysis using. The software is going to be the applications that are running the analysis, or the running that allow you to build the maps and things so they show up on your hardware. And then the data, so this is the geographic data as you can see here, such as locations, attributes, and spatial relationships. And so this would include any geospatial data that you're going to be used for your analysis or used for your maps. And then the people are the users. So this would be your GIS analysts and specialists, and then anyone who uses the products produced by the GIS. And so we often have had little discussions about which of these is the most expensive. It's probably the people, because people cost a lot of money to hire, but also data can be extremely expensive too. The software and the hardware end up being a very large upfront cost, but then they have pay for themselves down the road. And so you're going to be using a software program in this class that actually, if you wanted to use it on your own, would cost you about $30,000 for a license. So it is expensive, but you guys get to use it for free. You just can't make money off of it. Let's go on down to the next slide here. And so slide 2, what is topology? So with topology, this is one aspect to the study here, points, lines, and polygons, but the word actually has a bigger meaning, which unfortunately wasn't captured in this slide. So when we use the term topology in a more of a GIS sense, what we are talking about is in GIS software, every feature knows where it is in relationship to all other features, and those features know where they are in relationship to that feature. So if I am producing a map and it has fire hydrants on it, inside the GIS software, those fire hydrants know exactly how far they are from every other fire hydrant and in what direction. And then the converse is also true, where those other fire hydrants know where they are in relationship to that fire hydrant. And what that does is that allows us to answer all sorts of questions that would take a long time to answer if we weren't using the software. And so it saves us a lot of time and a lot of money, and it actually can answer questions that I'm not even sure people could with paper maps. And so this is talking about, unfortunately, I got this from a text, and this book is using it more as a study of geographic features, which is true. That's topology. This is the study of ology. But when we use it in the term for GIS more precisely, it's that concept that every feature knows where it is in relationship to every other feature. So if I ask you on the exam, that's what I'm referring to. Let's check down here. Examples, yes, connectivity. So it's getting to what I was talking about, but these are the aspects of topology. And so connectivity is how features connect together. Like your roads, you could have rules set where your roads the endpoints have to connect. And so that is one aspect of topology, is understanding that connectivity between features. And then adjacency is understanding how those features are touching one another, how they share boundaries. And so that's what we refer to by adjacency. And then we have containment. And so that would be how one feature can contain another feature. So you could have a polygon that has a line or a point feature inside of it. And I would actually add another one here called proximity. And so that's how close features are together. So if you were to be asked the 4 components of topology, your answer should be connectivity, adjacency, area containment or containment, and proximity. And so that's just what you would look at if you were studying the topology of your data. And so then here we're getting into the 2 data models. And so slide 3 is what is vector data. So what that means is geospatial data, the definition of geospatial data is any data that represent a real world location or a location tied to the real world. And so if I have a map and I have fire hydrants on it, and those are representing real fire hydrants on Earth, then we would say that those are geospatial data. And so because, a Word document, this slide presentation is technically an example of data, but it's not geospatial because these don't represent anything in the real world. So it's just tabular or just regular, we could even call it just regular data. And so there's 2 ways to represent those features. There's 2 data models. when we represent something from the real world into GIS. And those two models are vector data and raster data. And so you can now, when your mom asks you what you learned at school, you can sound super smart and say, well, just a little thing called vector data and raster data. No big deal, Mom. And she'll think, wow, I'm really getting my money's worth in that class. So you're welcome for helping out with that one. But vector data, if we represent a feature using vector data, so we can't just represent the feature. We have to choose one of these two models, or else it's not going to work in the software. So to represent the feature using vector data, what that means is we've represented it using either points, lines, or polygons. And so if we had the Sprague River, and I have a slide that shows this later on, but say we were representing the Sprague River and it runs down like this, hopefully you can see my mouse, what that would be represented in vector data is we could then use vertices and connect those vertices up with lines and create a representation of the Sprague River. And so the strength of vector data is that you'll see here that it's very accurate in how it represents the features. And also it has that topology aspect where that knows it's the feature. So I tell it it's the Sprague River, and then it knows I'm the Sprague River and I'm this distance from the Williamson River, or I'm this distance from Upper Klamath Lake. That's a component of vector data because they're features, they're actual objects. They understand where they are in relationship to everything else. And vector data is the most commonly used, but you'll see that if you get specialized in raster data, you make yourself even more hireable because it's not quite as common, but it's very powerful as well. So you're going to be seeing mostly vector data in here. If we have a feature set or a geospatial data set that's raster, I will tell you and inform you that it is. And we have some extra, you can see the extra advantages here. So it doesn't lose quality when zoomed in or out. Easily scalable, and it's efficient for analysis like distance and area calculations. So like I was saying. So the other one is raster data. What is raster data? And so raster data would include, this is if we represent the Sprague River as a grid of cells rather than points, lines, and polygons. And so we would have cells where it would be, this cell would be water, the next one would be land, then water, then land. And so that can be extremely powerful, but it's, the cells don't know that they're that the whole thing's the Sprague River. It just knows what that one particular cell is, what the value is. So that's where you kind of lose that topology where, it's powerful for certain analysis, but if you were wanting to know how many miles of the Sprague River are within a distance of, 10 miles of Highway 97, that's a question you can answer very quickly using vector data, but it's a question that would be impossible to answer. Actually, I believe impossible to answer with raster data, or if you did find a way to do it, it would be not worth your time. The structure of this, you guys can read through this. Just some things about the cell size and the resolution, and then we have some examples here. So satellite imagery, digital elevation models, also called DEMs, we'll cover those later. Aerial photography. Those are all examples of raster data. And there's two types of raster data. It's continuous and discrete. So if you were given a raster data set, you could categorize it in one of those two categories. And so with continuous data, what that means is you would expect a spatial relationship from cell to cell. So the next cell should have some form of spatial relationship to the cell you just moved from. And so those are things like slope, precipitation. So you wouldn't expect in one cell to get 10 inches of rainfall in a month, and the next cell to be 1,000 or 0. It could be more or less, but there should be some sort of relationship between the cells. So we call that continuous data. Same thing with slopes. I mean, you do have drop-offs and things like that, but usually if you're looking at the slope of a landscape, the cells will gradually change as the slope changes. And so there is some sort of relationship there. Whereas with discrete raster data, there's no relationship between cells. And so something like an example that would be zoning. So you could have an area of commercial zoning in a city, and then the very next cell could be industrial or something like that. There's not necessarily a relationship between the two. Now, the town or the city may have created a relationship, but there's not a necessarily one that's on the ground, if that makes sense. You can see here the advantages of raster data. It's excellent for continuous data. Like I said, elevation. They have elevation rainfall as examples here for continuous data. And it's useful in modeling and environmental simulations. So something like the U.S. Geological Survey, the USGS, they would use a ton of raster data because they use a lot of soil and geological data. And those things are really well done, really well represented using raster data, better than they would be using points, lines, or polygons. I mean, think about trying to represent soil data as just polygons. It changes so much, and there's so many different layers and everything to it that it would be a nightmare. But if you go cell by cell, you can then say, well, this cell is predominantly this type, this cell is predominantly that type, and now you start seeing how things look out on the ground a little bit more accurately. So here I've got an example here of the two. And so here on the left, you can see that this is being represented using lines and polygons. And then these are just the vertices are being connected up by lines. So this is an example of raster data. Whereas over here, we can represent the same thing, but using cells. And so you can see it doesn't represent it as accurately because of the cell size. But there's lots of different questions we could answer. So there really is no answer to the question which data model is better. It really depends on what the question that's being asked is. So the data model will be best depending on what you're asking the software to do. Slide 5, two types of geodatabases. So in GIS, you can store your data in folders. You can store them also in what's called a geodatabase. And so the geodatabase, it's just a container that can hold your data, and we will be using these. And the symbol for it looks like almost like a can of tuna or something. And but it's just a container, and it holds our data. And so there's a newer type called a file geodatabase here, and it stores GIS data in files on a disk. I'm not really sure why they phrased it that way, but it's a scalable and can store large data sets. So essentially a file geodatabase doesn't have a storage limit to it. You're really just limited by the size of your hard drive. And it can handle larger data sets because of that, no storage limit. And it's supported by most GIS software, so it's very versatile. And then we have here what's known as an enterprise geodatabase. And what that means is it stores your GIS data in a relational geodatabase system, and it's designed for large scale multi-users environments. So what this means is with an enterprise geodatabase, we can have multiple users accessing the same data all the time. And so if you had a large company that was using GIS, you'd want to store your data in enterprise geodatabases. And then there's one other type here, which this enterprise geodatabase, file geodatabases can be used as enterprise geodatabases, so it's not really a separate type. It's more of a designation for your geodatabases. But there is a second type of geodatabase called a personal geodatabase. And with the personal geodatabases, it has a storage limit, but it can be accessed using database software such as Microsoft Access. And so you can set up more complex relational rules within your geodatabase. So that's the advantage of the personal ones. They're a little bit older, and you don't see them as often. But if you have somebody who's really good at database setup and the rules, they would probably want to use a personal geodatabase because they can use something like Microsoft Access to set it up. The extension, so when I say the extension, that's just the little dot, 3 letters after the files. If you see a file geodatabase, the extension for that would be .gdb. And if you see a personal geodatabase, the extension for that would be .mdb. And so those store the data, but what are some of the types of data? So this is important, this is extremely important, any vector data set, so any vector data set is called a feature class. So if we use the term feature class, that's referring to any vector data set, no matter what type of file it is. If it's vector data, it's called a feature class. And an example of a type of feature class is a shapefile. So a shapefile is multiple files, and the software, so right here, this is what it's talking about, this component. So it actually comprised of multiple files here, and you can see their extensions. You don't need to memorize the extensions, but you do need to know like that the .dbf file is the table that goes with the data. And so if we were to look at a shapefile using I'll demonstrate this in the lab, using File Explorer, we would see these multiple files. It would have the same name. So say it was the Ethan shapefile, it would be the ethan.shp or ethan.shx, but they would have different extensions on them like that. And so that's all one shapefile though, because they have the same name before the extensions. And if we were to look at it using the GIS software, we would see it as one file, and it has a green symbol next to it, indicating whether it's a point, line, or polygon. And so shapefiles, they've been around for quite a while. They're very basic, but they're used a lot if you're just building a map or you're doing some very basic analysis. But it's important to realize that there are actually multiple files that are being shown as one file. And so what will get people into trouble is they'll try to send their shapefile to a friend, but they'll attach, when they go to attach the file, they'll attach just this .shp file, and they'll forget to attach these ones. And so what that does is that then makes it so that the shapefile doesn't work when your friend gets it, because it's only one part of it. So shapefiles are an example of a feature class because they're vector data, but not all feature classes are shapefiles. So it's the old Venn diagram thing. They're easy to share. Their limitations: they're limited in size, 4 gigabytes maximum. Does not support complex data structures, i.e. topology. So what that means is that with a shapefile, you can't set up rules about how your shapefile interacts with other shapefiles. You have to import the shapefile into a geodatabase to set those up, and then it's no longer a shapefile. So that's important to realize. This is super important. Is that once a shapefile is inside a geodatabase, it ceases to be a shapefile, and we just call it a feature class. I had an instructor tell me once that if he was doing a job interview and the person referred to shapefiles inside a geodatabase, they wouldn't get the job. It's that fundamental of a concept, is that your shapefiles always exist within folders. They do not exist within geodatabases. If you import it into the geodatabase, there's a transformation that happens that's no longer a shapefile. It then becomes just a regular geodatabase feature class. Now, I did say shapefiles are feature classes, but this is more of a generic term, whereas the ones that are inside the geodatabase are a specific type of feature class, which we refer to as geodatabase feature classes, or often people just use the term feature class for it. I realize that gets complicated, but it's really just because people are being more sloppy than anything else. Just remember that geodatabases do not store shapefiles. And I think it's going to help you guys understand a lot of this once you see the data, because I'll show you examples of each of these. And then we talked about this, the two types of raster data. We have discrete and continuous. You should know what those mean. And you should have 22A category IEG forest, yeah. And continuous raster data represents continuous. Yeah. Yep, so this is essentially saying it a little bit different than I did, but it means the same thing. And get the examples of both. So those are the two types of raster data. Okay, so that concludes the end here of the first lecture. and I will then proceed to show you how to download your data and how to set up your file structure. And then we'll start actually getting into the software and having some fun with it. You will need your ArcGIS Online username and password. So if for some reason you have not received the email asking you to set up your password, please let me know as soon as you can, and I will make sure that happens. I think everybody has theirs now, but if for some reason you don't, that means that you fell through the cracks somehow. And so just let me know one more time, and we'll make sure you get it. But you will need that to log in and to receive your software. I'm going to put a link on Canvas on how to download the software. You will need to be using a Windows machine. It will not work on a Mac machine. There are some ways around that using emulators, Windows emulators. If you want to go down that road, I will not stop you, but I cannot help you do that. So if you're wanting to try that, you can always Google or search on YouTube, how do I run ArcGIS Pro on my Mac? And there are workarounds for doing that. It's just not something that I can help you with. Much easier to use a Windows machine. If you have access to Campus, let me know, because you can use the GIS lab, and I can get you in there to run through these exercises. So we're looking at about 25 minutes there for the lecture, and I will then be on creating the exercise here next. And it's just up to you just to work through this as you go. And it's up to me to help you do that with as little difficulty as possible. Okay, I will see you in just a jiffy with the exercise.
Okay, so I've gotten logged into Canvas here, and I went to the announcements where I announced that I was attaching the course data. I'm in student view, so this is how you guys would see it as well. And all I need to do is download the data from Canvas, and so it's right here. It's this GIS103.zip. All I have to do is click on it. It'll then download into my download folder, okay? And then I am going to go grab it and move it into another folder here. So you should grab it, copy it, and paste it into a GIS103 folder, which I actually did ahead of time here. So it's like I went and grabbed it. I created a folder called GIS103. I called mine 2024 because I've got quite a few of these on my computer. And it's under my data folder on my D drive. Yours can be on your C drive or your desktop. And I just pasted that zip file into that folder. Okay, and I've got the lecture notes here. And so now what I do is I right click on it. I go to extract all. It's then asking me, hey, where do you want to put this? And I'm going to tell it I want to put it in my GIS103 folder. That's great. And extract. It's then pulling all the data out of that zipped file. It was compressed. And so now you'll see that if I go to my GIS 2024 folder, I've got two GIS103s in there, one that's zipped and one that's not zipped. I can now, because this one's a copy, I can delete the zipped one. And now this one's got my data in it. I don't really love the fact, no, I'm okay with this. Yeah, so I've just got a GIS103 underneath my GIS103 2024. That's fine. If you're OCD about that, you can actually just pull everything that's in here out and then delete that. Which I can, oh, there's another one. Okay, so you don't have to do this, but I'm going to click one, hold shift and click the bottom one, and then I will copy it, bring it out to here, paste these there. Okay, and then I will delete this one. Okay, didn't change anything, just moved it all out farther up the file structure. And let's add actually, we can actually delete this MXDs file folder. We don't need those anymore. and that's okay. The rest of that's okay. And then let's right click in the white area, go to new folder, and let's create a results folder. And this is the one that you guys will copy. You'll zip it up and you'll send it to me when your assignments are due. So the first assignment's due around halfway through the class. Second assignment's due at the end of the term. You'll just zip this up and I'll be able to just grade the whole thing then. And so let's go inside the results folder and let's create a week _1 _2. Okay, so I'm using underscores because this is important when dealing in GIS. When you're either dealing with geospatial data or paths to those data, thou shalt never, this is one of the 10 commandments in GIS, thou shalt never, ever use spaces. It messes the software up to do that, so here I know that this is going to have data in it, so I used underscores instead of spaces. I'm saying this is week 1 and 2. You don't want to use hyphens either. You don't want to use any special characters like ampersand, pound sign, as you guys call hashtag, @. Don't use anything like that. You want to, and you don't ever want to begin this with a number actually either. So week 1 and 2, and this is where we're going to save our stuff for today, because this exercise will cover the first 2 weeks. It's technically, I guess it's technically week 3, 2, and 3, but week 1 was just 1 day, so I'm counting this as week 1 and 2. And if I refer to it as 2 and 3, I'm sorry, but it's just the way it is. So I download the data, I unpacked it, and now I posted in this announcement with this video, there is a link to another video that shows you how to download ArcGIS Pro, and you can do it as long as you have your ArcGIS online username and password. And so if you have any trouble with that, it does not work on iOS. There are some workarounds, like I said, but you've got to figure those out on your own. We can't really help you with that. And then also, if you are struggling to install the software, the best resource is to call Esri themselves. So that's the company that produced it. Call their technical support, and they can actually walk you through it much easier than I can ever help you. I'm not really supposed to help you guys with your own machines, your own computers. And so if you're having any trouble with installing the software, which you shouldn't because you don't have any other versions of it on your computer, it's a lot more difficult to install if you have other versions. But if it's your first one, then it should be pretty smooth. But if you do have any issues, let Esri's technical support know. Tell them you're taking a GIS class. You have access to ArcGIS Online, which means you should be able to download the software. Okay, having said that, I'm going to open up ArcGIS Pro. So if you don't have it downloaded yet, pause the video, go do that, and then follow us. So I go to the start button, and I search for ArcGIS. There it is in all of its glory, and we will let it run. Might take a few moments to open up, especially the first time if it hasn't been open for a little while. Okay, so the first thing that I'm going to do, you don't have to do this, but I think it's pretty awesome, is I'm going to put mine into dark mode. So I'm going to go over here to settings, and I'm going to go to options, and then I'm going to go down to general, application theme, dark. I'm going to then click OK. I'm going to close the program and reopen it. I like dark mode. It's a lot easier on my eyes, but I realize not everybody prefers it. And so this is the brand new version, the brand new updated version. So there might be a few things here that I'm not used to. I haven't used it a ton yet. But in theory, it should be similar to the one before it. Okay, so then you find this screen here. It's in dark mode. Yours might be in light mode. Normal users, that's not us, but normal users would just click on map. And then what would happen is the program would create a map, a starting map. It would create a geodatabase. It would create a folder for you and throw that all in a location for you. That doesn't work very well for us because we are working out of our GIS103 folder. And so we don't want it to continue creating new folders every time we come in here. So we're not going to click on map. We're going to go over here and click on start without template. And that's what we'll always do unless you're opening a map that you've already worked in. This then opens up a blank map. We'll give it some time here. I'm not going to go through the video and speed these parts up because I think that'll make it so that I'll get ahead of you guys if you're following along. And so I think it's better just to let it do its thing. And that way you guys don't have to try to pause and rewind the video if I get ahead of you. Alright, here it is. And so just a little bit of navigation here. It has this right here is where all the mapping will show up. All the layers that will display out here. These here are unfortunately named, I don't think this was the best idea, but they're named panes, P-A-N-E, not P-A-I-N. But this is your contents pane. Sorry, this is cutting it off a little bit here, but this just says new map right here. And I'll always say what the buttons say. So, and then over here, this is called the catalog. Oh, this is a geoprocessing pane. This probably isn't open on yours. And then here's the catalog pane. If it's not over here, check and see if it's along the edge here. You'll see it says catalog along the edge. Just click it and it comes out. And you can click this cute little push pin if you want it to stay out all the time, which I think I usually, yeah, I think I prefer that. But this essentially, what catalog is it's like File Explorer for Windows where you can look at your files and documents, but it's a GIS version of it, so it shows all the GIS files how they should be shown in GIS. So whenever you're adding data to the map, you need to use this or an Add Data button, which is on the, let's see, which tab is it on? It's on the Map tab. So there's an Add Data button right here. It's grayed out. Okay, so what we have to do now is we have to allow our folders, right here underneath where it says folders, we have to add our folder, okay? Because right now you probably just have this one and that's not going to help any. So we have to tell the software to see our GIS103 folder. So I'm going to right click on folders. I'm going to click Add Folder Connection. And then I'm going to go to, for me, so you just have to remember where you put that GIS103 folder. For me, it's under this PC, the D drive. Yours might be on your C drive. Mine's on my D drive. And I'm going to go to GIS. I've got a lot of stuff on my computer. I'm going to go to GIS103 2024 for me. And then I'm going to just stop it there. That's as far as I want to go. And so I'm just telling the software, hey, I want to see this folder all the time. And so if you have other folders that have data in them, you can also add them. And so now if I open this up, hit the arrow, I can go down to GIS103 data. And I've got geodatabases, which has nothing in it right now. And I've got shapefiles. So see, these have the green symbol. And just to illustrate the point that I was talking about earlier, you see how these are each a single file? Like this lakes.shp. Well, let's go look at it with File Explorer, which is down here. File Explorer. We go to the same folder, shapefiles. Ah, look at that. So now if we look at lakes, we've got lakes.cpg, lakes.dbf, lakes.prj, lakes.sbn, .sbx, .shp, .shx. So if I wanted to share this lakes shapefile, it's kind of hard to say. If I wanted to share this lakes shapefile with somebody, I'd have to attach all of these to the email or put them into a folder, zip the folder up and send the folder to them. Okay? But you'll see that now in these GIS software, it sees them as one file. Okay? So let's go ahead and add, let's right click on our FS roads. These are Forest Service roads. Go to add to new, and we're going to tell it to create a map right now. So add to new map. It's going to then create a map and add those roads to it, and it's going to probably include 2 background layers as well. So, yep, we got world topographic map and world hillshade. So real quick here, you'll just see that one of those is just a regular map, and the other one, the hillshade, this is a raster layer. It gives it that 3-dimensional look. Okay, and these are coming from Esri. So they're letting us use these. They're pointing to their server. This is stored in my GIS103 folder. Okay, and so this map, it doesn't actually contain these data. It's showing that it's pointing to them and then just symbolizing them. But they are living on your computer in your GIS103 folder. That's important to remember. We'll talk about that more. Okay, so let's just talk about navigating around the map. So you can just pan. And look how smoothly that pans. That is really amazing. That it doesn't have to refresh to do that, because that's actually a lot of data. So you can pan. You can use your roller ball or your roller wheel on your mouse to zoom in, zoom out. You can go to the map tab up here and the Explore tool, visible layers. So you can click the Explore tool. It allows you to pan and then click on things and identify them. So, it's kind of a pan/identify type tool. If you don't like say I was, I had a seizure or something and I was like that, whoa, like that, you can click the back arrow here to take you back to your previous view. You can click the forward arrow to take you forward to your next view, or the one that you had before that, or you know what I meant. These are fixed zooms, so they zoom in and out, just keeping the center right in the center. Kind of looks like a movie. You can zoom in all dramatically like a movie doing that. This one takes you out to your full extent. Bookmarks. So if you like the way your map looks, you can create a bookmark. And then if you accidentally move it or pan it or get it all screwed up, you can go back to your bookmark. Go to XY, so this you can punch in an XY coordinate and it'll then zoom into that particular XY coordinate. Base maps, these are pretty cool. So if we go, you should have logged in when you signed into your map. It should have had you log in. I'm already logged in here. You see it up here. It says Ethan OIT. geomatics department. If it doesn't say that up in the upper right, you want to click there and log in using your ArcGIS username and password. Even though this is Pro, you still need it for this to get the full functionality. So if you are signed in, you can then go to base maps, and it'll load up all these base maps that Esri has. And there's some really cool ones in here. This one here, Human Geography Dark Map. I mean, there's just really cool stuff. I mean, look at that. And I can undo my FS roads. I mean, it's just really nice. I love these dark maps. I think they look so nice. So this would be a great background layer if you were making a dark map. Oh, so nice. So awesome. Darth Vader would be proud. So those are the base maps. We can uncheck that. They're coming from Esri. It's funny they say human geography. It's kind of a funny way of putting that. Okay, so let's turn our roads back on. So right now all we have are our roads. And we'll zoom into them, use our roller ball. So you can also do this. You can right click on the layer and click zoom to layer. That's really handy. Okay. And mine is still doing this because of that human geography map being on. It's dark like that. But I'm going to leave it on because I actually like it. That is really easy on my eyes. So you guys don't have to leave it on, but I'm going to. So let's talk about selecting features. So there are 4 ways to select features in GIS, 4 straightforward ways. There's other ways you can do it. But the 4 main ways are, and this will probably end up on a test at some point. So the 4 main ways are to use the select tool. So underneath map, you can go to the select tool. Just click it. And you can just straight up click the road like that. You can make a box like that. Look at that. Choo, choo. You can change the method for selecting. By clicking the arrow, you can make a polygon, a lasso. You can be a cowboy. Shoo, just lasso. Look at that. That's the select tool. You end up not actually a circle, a line, trace, a box, circle, boom. Cool. You don't end up using that tool a ton because usually you want to select things more specifically, but it's good to know it's there. And then here's clear selection right here. And so whenever in ArcGIS, whenever you run a process or an analysis, it only runs it on the features that are selected. So before you do that, you should always check this and see if this is not grayed out. Because if it's not grayed out, that means you have something selected. And it might just be one little tiny little line segment. So you always want to check on that to make sure that you don't have anything selected. Unless you want to only run it on the selected features, then it's fine. So the select tool is one way. The next way is to select things. Sorry, I have an itch. The next way is to select things in the attribute table. So in GIS, all of these features have a record inside the table that is associated with that feature. And every record in the table has a feature out here that's associated with it. And so if I select something, I'll show you. So I'll select this road. And here, this is good to know too. If I hold shift when I'm selecting, I can then add to my selection. See how I'm adding? It's not just replacing it. If I let go of shift and then click one, it just creates a new selection. Okay? So I'm going to select a few things here. And now if I go into my table, right click on FS Roads, Attribute Table. You can see down here at the bottom of the table it says I have 3 out of 6,080 selected. So to see those 3, I could just hunt through this table and find them. Or down here at the bottom of the table I can click this, which is Show Selected Records. click that and you'll see these are the three. And so if I right click on one of them on the number and I click flash, see that? It will flash whichever one that one is. And I can also click zoom to or pan to. So zoom to, there's that little road. Okay. And so this is the other way that you can select things. So if I go up here and I click clear, up top here I click clear. Now they're gone. See, they're not gone. They're just not selected anymore. So they're still in here, but it says 0 out of 6,880 selected. So this is the other way you can select, is by just clicking the numbers. So if you saw it in the table first, you could select it. And if you want to do more than one, you can hold Control. If you want to do all of the ones in a row, you can hold Shift. So if I click on 4 and I go down to 13 and I hold Shift, it gets all of them. And then I can hold Control and deselect ones out of there if I wanted to. Okay, so let's take a look at the other ways to select features, numbers 3 and 4. And those are up here under the Map tab. And they are all right, so let's take a look now. I closed that table, so let's take a look now at what the other two methods are for selecting features, and they are the most powerful, and they are known as select by attribute and select by location. So just as an example for illustrative purposes, a select by attribute would just be using something out of the table, and select by location would be a spatial relationship that you're using to select with. And so if we had students in the classroom, we would say if we wanted to select all of the students with blonde hair, that would be a select by attribute, because that's something we would store in the table. Or if we wanted to select all of the students sitting on the left side of the room, that would be select by location. And then you can combine the two, so you could start saying, well, select all of the students with blonde hair sitting on the left side of the room. And so learning how to do that's really powerful. You have to start thinking pretty logically. But I think that won't be a problem for us. So let's take a look at those two. So they're up here on the Map tab. And I am sorry if I sound tired. I just recorded the rest of this for 40 minutes and then it didn't work. So I am redoing this and I'm kind of not happy about it. So up here we have select by attribute and then we have select by location. So select by attribute, let's go ahead and open that. And we're going to select let's go with the Paisley Ranger District. So we could just go in the table and find Paisley and select it. But what if we had 8,000 records? Or what if we had 25,000 records? Now if you're paid by the hour, you might want to sit there and go through the table that long. But we're pretending that we are salary employees, and so we want to find the most efficient and economical way of doing everything. And so we click select by attribute. This input rows here, this is asking what are you selecting from? And we're selecting from our row, we're Ranger Districts, because we want the Paisley Ranger District, excuse me. Selection type is saying what kind of selection are you doing. We are creating a new selection. You can see here that there's lots of different options. You can remove from selections, add to selections, and you can save your selection expression. If you really used it a lot, you could save it and just throw it in here. And then here it's asking, okay, well, how do you want it to read? Well, this is called an SQL statement. It's made it nice for us and easy to use. You know, if you clicked here, you would see what they looked like normally. But this is making it nice and easy. And so we want where. And in that table, we saw that district NA gives us the names. I think either of these would work, but we're going to district NA is equal to, and then you choose Paisley to drop down, excuse me. the Paisley Ranger District. And then we could add another one, but we're going to use this just for now. So we're going to click OK. If you click OK, it applies it and then closes the window. If you click Apply, it just applies it and keeps the window open. So they do the same thing. It just depends whether you want the window to stay open or not. There's the Paisley Ranger District. So to double check our work, we open the attribute table for the Ranger Districts and we should see Paisley selected, and it is. Okay, we can then view just the selected records by clicking down here, and there it is. Alright, cool. So now, what if we wanted to select all of the roads that are completely inside these ranger districts, okay? All of the roads that are completely inside these ranger districts. So first let's clear our selection. So up here we click clear. Because remember, if we don't clear our selection, it's going to operate only on the selected feature. We don't want that. So then we go select by location. Again, input features is saying what are you selecting from? We're selecting from the roads now. Ignore this .gdb. Yours is going to have, or this GDB on the end. Yours is going to have, just say roads. Same thing. It was something I did that got deleted, and I don't want to have to go back through it again. So just ignore that. Use your roads. And we want the ones that are completely within. So the relationship type is going to be completely within. The selecting feature is going to be our ranger districts. We don't have a search distance. That'd be if we wanted to add some more onto it. We could. And we have a new selection. We're creating a new selection. So let's go ahead and apply. And oops, barked at me because I don't have my... Okay, yours probably worked. I have to grab the old set of roads. So hang on a second. Yours probably worked. Remove this one so I'm confused. So yours should be selected. Let me rerun mine using the original set of roads. FS roads. Okay. Completely within ranger districts. New selection. Run it. Okay, there they are. So all these roads are completely within. So if you look down here, these ones are not selected because they're not completely within the ranger districts, okay? So let's say, what if we wanted to create a feature class just out of those roads? Well, let's create a geodatabase and put them in there. So to do that, we go to, over here in the file, we go to our GDBs folder underneath GIS103 data. Right click on it. Go to New, File Geodatabase. There's that can of tuna I was talking about. Let's call it week 1 and 2. No spaces. And then to put that in there, we can't just drag and drop things in there. We have to export and import them in. So to do that, since we have these selected, we know that's going to do it just to the selected records. We right click on FS roads, go down to data, export features. And then right here you'll see it has this toggle to use the selected records, 5,719 of them. And if we undid that, it would do all the records, but we want that selected. The output is going to go click the little folder here. It's asking you, hey, where do you want to save the new one? We go down to, sorry, this is kind of weird the way this is set up. So we go down to this PC and data, GIS 2024. Oops, I'm in 307. Hang on, wrong class. GIS103, 2024. Data, geodatabases. Inside that geodatabase, give it a name. These are roads underscore, excuse me, within RD, Ranger Districts. No spaces. Save it. Run it. And then it adds it to the map. You'll see over here inside that geodatabase, we now have stuff. Okay, this is the old one that didn't work. So I'm going to delete that one. And then this is the new one. Did I accidentally put it in the old one? I think I may have. Right click on it. Refresh. Yeah, nothing in there. Okay, hang on. Sorry guys, it just really messed me up in that video, didn't. So I'm going to rerun it here. I'm going to right click on my roads, go down to data. Export. Output. Go back to here. And 2020. Oh, I did it again. How about that? Same mistake twice in a row. Okay, 103. GDBs. Refresh. Okay, I'm going to recreate the geodatabase then. So your guys' has probably worked. Okay, so once that export, I had to do a couple things there because it's still messed up from my thing not recording. But once that exported, now you should see that now all you have are the roads that are completely within. Now, don't get confused. This is not the same thing as clipping this and cutting them. If there was a road that crossed here, it would just not be included. So don't, that's why there's a lot of stuff missing up here. So don't get that confused. It's not the same thing as a clip. Now, I know that you guys don't know what a clip is yet, but you will. So when we do clip things, don't say, well, I already did that by doing it this way. They're not the same thing, okay? But that's how you create a geodatabase, and that's how you export things into said geodatabase. So you'll see right now I've got that roads layers in there. And so now let's do a little bit fancier analysis. Go ahead and let's take a screenshot here to prove that you guys have made it this far. So we go down here to the Start menu. Search for the snipping tool. Click New. And then take a screenshot of your map here and make sure that you've got that geodatabase open, showing that you've got the roads and the RD in it. And then go to File, Save As, and save it under your Results folder. Create, if you haven't done this already, create a Week 1, 2 folder underneath your Results folder. So you just right click in the white area, go to New Folder. And then inside that folder, here's some of the old ones that didn't save. Save this in there and call it, let's call it Created Geodatabase. Okay. And then we just click Save. And you can close out of it. Okay, so when you zip that folder up and send it to me when assignment 1's due halfway through the term, I can then get in there and see those screenshots, and it proves that you worked along with me here. Okay, Let's do something a little bit fancier here. Let's see the level 1 and 3 roads that are inside the Paisley Ranger District, okay? Level 1s and 3s that are inside the Paisley Ranger District. So to do this, we have to use we can just select things, but there's something that I think is even more powerful and more useful, and it's called a definition query. It's one of my favorite things in GIS, and I'm going to stop this video real quick and restart it to make sure that I got this far. And then we'll talk about definition queries, and I'll give you guys as your little assignment at the end here. So, one sec. Okay, so that recording worked, and so we're back at it again. So a definition query, what's different about that is I could tell this just to symbolize the ranger district. So to change the symbols, you just click on a symbol underneath it, left click, and it takes up the symbols here. There's a lot of preset symbols. Over here you can then also go to properties and you can change the color, the outline color and everything. So I could tell it not to only show the Paisley Ranger District, but what will happen if I do that is in the table the other ranger districts will still exist, and so that doesn't help, okay? It's only for display purposes. But what a definition query does is it tells the software, pretend like this is the only thing that's true, and then it does it until you remove it. And so it's really slick because you can create these intermediate layers and then bring back everything after you're done. And so to do a definition query, we can right click on ranger districts and go to properties, or we can double click it, which I think is better, or faster at least. So we double click ranger districts, and the interested student would say, let's click on definition query. And you'll see here it says new definition query, so we go ahead and click that. Now this is built very similar to the select by attribute, where something is equal to something. So we want where district NA is equal to I clicked district name. Sorry. District NA. I was confused there for a second. Okay, district NA is equal to Paisley. And then we can click apply and then click OK. Boom. Just Paisley. Kind of looks like Massachusetts kind of on its side, huh? Or almost upside down. Let's take a screenshot of this one and save it in there. So start menu, snipping tool, and I'm going to stop telling you how to do this here in a second. Take the screenshot of just the Paisley Ranger District, go to File, Save As, name it Paisley_RD, and then click Save. Okay, I'm going to cancel out of mine because I already did it. And now, if we want to do the 1s and the 3s, let's go ahead and uncheck our roads within the ranger districts and just use the FS roads again, the original layer. Clear our selection. And now we are going to, we want just the 1s and 3s, right? So to do that, we can go to select by attribute because it's in the table. Select by attribute. And we are going to selecting from not the ranger districts but the roads. Selection type is a new selection. The expression, we have to uncheck this SQL thing here to get back to the original one. Maybe, if it'll let me. Okay, well, let me delete all this. And now uncheck it. Okay, that was weird. Okay. Where opermate is equal to 1. Now here's where people get stuck, okay? This is really important. I'm going to add another one because we want the 3's as well. And we can't just go equal to or less than 3 because it'll include the 2's. So you could do that and then remove the 2's from the selection. But I think it's easier to do it this way. So we're going to add a clause. And here is where people get stuck, is they use and instead of or. We want or because if we choose and, that's saying both of these have to be true in order for it to select anything. And there's never going to be a record where a road is a 1 and a 3. Okay, it's either or. So if I wanted and, I could do, students that are over 6 feet tall and have brown hair. Then I would use and because I want both those things to be true and they're in different fields in the table. Okay, but we're going in the same field, so we want to make sure we use or. And so then we go back to operate. Is equal to 3. So it's going to look in the table and see if it says it's a 1 or if it's a 3, it's going to select them both. Click apply or click OK. There they are. So now if we want the ones that are only intersecting the Paisley Ranger District, we can go back into select by location. We're selecting from the roads. Okay. That intersect. The selecting feature is the Ranger Districts, which right now only has Paisley, which that's why this is toggled here. Use selected features. It's considering the definition query to be a selection. That's fine. This is new, actually. You used to not have this option. And then there's no search distance. It's not a new selection. Okay, it's not a new selection. We want to select from the selection. So it's not adding to it. It's not removing from it. It's selecting a subset from the current selection from our 1's and 3's. And then we click OK. And there they are. And to do a little check here, we can open up the table for the roads. We can go to the operate field. And we can right click. Now we're going to look at just the selected ones. Okay, so let's go back and look just selected. And then we're going to right click on operate and sort ascending. They're just 1's, starting at 1's. Sort descending, and they're ending at 3's. So I know there's no 4's and 5's in there, so that's a good sign that we did it right. Now I could go back and check and make sure there's no 2's in there as well, but I want to get this out to you guys. So now your assignment is 2 things. Three things. Take a screenshot of this and save it in the results folder. Okay, what we've done here. Then save, like we did earlier, save these selected roads as a new feature class in that same geodatabase. You have to go back and figure that out if you don't remember how to do that. And call them roads 2's and 3's inside Paisley. No spaces, remember. And then do a second one where you're doing anything 2's and below. So 1's and 2's that are inside the Klamath Ranger District and the Chemalt Ranger District. Okay? So we want to do a definition query that shows both Klamath and Chemalt, and then use that to select the 1's and 2's. Okay? So the 1's and 2's that are inside both the Klamath and the Chemalt Ranger Districts. And then do a screenshot of that and put that in your results folder, and then you're done. So to recap what we learned how to do, we learned the methods of selecting features. We learned select by location, select by attribute. We also learned how to do statements in there, where this is equal to that, and so forth. We learned how to add to selections, how to clear selections. We learned a definition query, how to create a geodatabase, and how to export features into that geodatabase or also import them into the geodatabase. And so got several things here, but it's like a cake. We keep building on it, so make sure you understand what we're doing really well so far. If you want me to check something for you, you can always send it to me. I'll check it out. Or if you have questions, something wasn't working, let me know. But whew, we made it through that. This covers, if you're traveling, trying to travel on time here, this covers week 1 and week 2, which I know it's like technically 2 and 3, but this week and next week. And I know that some of the things in here say 2024. If this is for a future class in 2025 or 2026, hey, how's the future? But sometimes I like to try to get a couple years out of these videos because they do take a long time to record. So don't freak out because mine says 2024. Yours should be the same in 2025 or whatever. Okay. Save those. You'll want to save your map if you go up to Project. Save as, save project as, and then you will save it. What I did is underneath, see, I've already done this because it didn't record. So if I go back to my GIS103 2024 folder, I created a new folder by right-clicking, clicking folder, and I called it Map Documents with an underscore, and I saved this map document inside there, week 1 and 2 is what I called it, okay? And then you should be able to close out of it, and then we'll pick this one up next time, so I'll reopen that map document, and we'll keep working from there. There's the recording software. So thank you guys for your patience. We'll make it. We'll persevere. They cannot hold us down. And I will see you guys on the next lab, in the next lab. As I always have to say at the end here, laters on the Minjay.
Latest on the Menjay.